Good afternoon. Thank you for coming and thank you for having me here. My name is Michael Kölling. I work at the University of Kent in Canterbury in England, in the southeast corner of England, pretty much opposite the Channel Tunnel, so we can look over to France from there. And I've only arrived here in the US last night, so I'm still out of my time zone, but I think this time isn't too bad. If it hits me in the middle of my talk that I suddenly get tired, then I'll just drag on to the end. I want to talk to you today about the topic. It's on the screen there already, teaching kids to code. So I want to talk a bit about what we do to teach programming to kids. In this case, it happens to be Java, and that is maybe one of the things to talk about as well, whether it's a good or a bad thing. I will spend my time doing mostly software demo. So I will show you a system called Greenfoot that we use for teaching. And first I thought I'd give you an introduction, the typical few slides with a background, and then I do the demo, and then I thought I'll skip all that, and I do mostly demo, and I sprinkle what I would have said in the introduction somewhere in the middle, and maybe that's a little more interesting to see. The thing about software demos is you've probably seen many of them, and there are very different kinds of demos, and I have recently seen a magic trick that reminded me a lot of the way how many software demos are, and I thought I want to show you today, just to, you'll understand what I mean. The trick is a very classic trick, classic magic. So it's the cut the rope trick. So you probably have all seen that at some stage. You have a standard bit of rope, and I'm going to cut it in half, and then I put a knot in it, and then I'll do my magic, and then the knot is gone, and it's all in one piece again. So that's fairly standard bit of magic. So here's my bit of rope. I'm going to cut it now. Has anyone got a pair of scissors on them? Well, if you don't, it doesn't matter because I'm well prepared. I've got one that I made earlier here. So I've cut that already. And I'm going to put my knot in it now, which I'm not terribly good at. But, well, it doesn't matter because I've got one that I prepared earlier. And now I'm going to make this knot disappear. So I'm just count to 3, and then it'll go away, and we have one bit of rope again. 1, 2. Well, it doesn't matter because I've got one that I prepared earlier. And here we are. And that is pretty much how many software demos are going that I've seen at many conferences. And then at the end, you wonder, what you've just seen. So I hope that I'm not going to do this, but really show you everything from start to finish, so that you get an impression of what the system really is. The system itself is called Greenfoot. Greenfoot is a system, it's essentially a programming environment that we have built explicitly for teaching programming to young beginners. We had another system before, well, it's still around. We built another environment for teaching previously that was called BlueJ, that was aimed essentially at entry-level university students. So we had talked for some years already in the context of BlueJ about teaching programming to beginners. And in our mind, that was always first semester university. But the truth is that first semester university now is not the first contact of kids with programming anymore. And we thought we've said for a long time that we want to do, teach programming in a sort of pedagogically valuable way and good way right from the start. And the start is just not entry-level university anymore. The start, in fact, and where we lose them already is at school level. So we thought that if we're serious about doing it in a good way from the beginning, we really have to go a bit lower than that. And there's one big difference between teaching at university level and teaching at school level. And that is, if you teach at a university, which is my day job, you have a much easier time because you have a captive audience. They can't run away. They have made a choice to be there. And I'm inclined to say they want to be there. That's not always literally true, but in some sense of the word it is. You know, no one forced them to be there. Well, maybe their parents did, but by and large, you know, they are interested. Whereas if you are one of the school teachers, you know, the poor people having to stand there with 15-year-olds, 80% of the students, before you even start talking, have already decided that they're not interested. And so that is one of the main differences, is that a lot of what I'm going to show you is about generating motivation, you know, being sort of fun, being engaging, so to draw them in. So what we're trying to do here is two things at the same time. We're trying to teach them something valuable, but at the same time, we're trying to do something that they actually want to do, to draw them in. I'll just go ahead and show you some things, and then I'll give you a bit more background later. So what I've got here on my screen at the moment is Greenfoot, and I'm just opening another project here. So here, for example, I have an existing Greenfoot scenario, we call them. A scenario is essentially one project, where I have here on my right a representation of the classes that are involved in this project, and here I've got what we call the world. So I have already written some classes here. So these are Java classes that are implemented, and the first thing we typically do is not to write code, but to start interacting with classes. So when I have a class here, I can click on it, and I get a pop-up menu with a few operations, and one is to instantiate this class. So I can create a new object here of this class interactively. And when I do this, I can place my object into the world. And when I have an object in the world, I can click on the object, and I can see all the public methods of this object. And I can now interactively invoke these methods. So I can tell this wombat, for example, to move. A wombat, by the way, is an Australian animal. I don't know whether you've seen that. A funny-looking, you know, looks something like this, you know, modulo my drawing abilities. So I can now interactively invoke these methods. I can tell it to move. I can tell it to turn left. I can make it move again. I can also invoke methods with parameters. For example, here I've got a set direction method, and I can type in some constant, and then it will move in that direction. I can have method results. So for example, here my can move method checks whether the wombat can move forward at the moment. So if I invoke this, it returns true. And if I move him here to the edge of the screen and then ask, can you move forward now? It says false. So what's happening here? Well, and another one thing I should show you maybe, I can create more of them. So I can create now as many wombats as I want. So what is happening here is that I can introduce valuable concepts of object orientation in a very concrete way. So I can talk about the relationship of classes to objects, you know, that from a class you can create many objects. I can later get to the relationship to the source code as well. I can essentially tell the story that we can communicate with objects by invoking their methods. So every object has a set of operations that you can perform on them. I can talk about parameters and return values and so on. So I can, first of all, introduce the fundamental concepts of object orientation before I have to talk about where the curly brackets go and the semicolons and things. So it's a sort of top-down pedagogical approach where we don't start with all the little, you know, tedious detail, but we start with the big picture. I can then click the Act button, which makes them all go forward at the moment. Every actor class. So Greenfoot gives you a framework that consists of a world and multiple actors. Every actor, by definition here, has an act method. And if I click the Act button, that act method of every actor in the world gets called. And so if I click the Run button, Run is just a loop around act. So if I do this, they all just run around. I can then put leaves into the world. And if I put some of those in and I put some wombats around, if they run around, they go around and eat the leaves. And I can then look at them and say, okay, how many leaves have you eaten? And I can, so I can discuss in this context the concepts of state, that there's different objects and they have a different state, and one has so many leaves, and I can interrogate them about this. I have here an example that I may use at the beginning of teaching. So typically, I've said just in my remark about demonstrations, I said I wouldn't hide anything. So I'll just show you briefly how to really start from scratch, because here I've got an example already where I've prepared something which is the normal way a teacher would start teaching. But just for you, I'll also show you how it works to create a scenario from scratch. Although in a teaching situation, that wouldn't be the first thing I would be doing. In a teaching situation, that comes a little later. So I'm creating here a new, oh no, I've selected open instead of new. That won't work. So I want to create a new scenario, and I can close this one. So this is what I get when I create a scenario from scratch. I always have the world and the actor classes. They are part of the Greenfoot framework. And then I can create a subclass of the world, and I call it, let's see, I've got some backgrounds here. I've got an image of a brick, so I just call it wall. I make a brick wall. And so in addition to the typical name of a class that Java classes always have, in Greenfoot, there's also an image associated with every class you create. And if I now create this and compile it, there's my world. And if I open the source code, it gets a skeleton automatically, and there's not much in there. This is really the interesting thing. This is the size and the resolution. So let's say I want a 1 pixel resolution, and I make it 400 by 200. Oops, 202. Well, that's good enough as well. So here's my world. It's a bit bigger. And then I can create a subclass of an actor. And let's say I create a bug. And you see here is a library of images. You can select any of the images that come bundled with the system, or here with the browse button, you can use any image that you have anywhere in your file system. So for students, that means that very quickly they have pictures of their teachers running around and getting eaten by monsters. And that goes always really quickly. So I can see somewhere here, there are some, yeah, that's a good enough image. So once I compile this, I can immediately instantiate a bug and put it in here, because the default skeleton that every new class gets is syntactically correct, so it compiles even though there's no real code here. And then I can do things such as set location. I've got a set location method. I also have a getX and a getY method. And of course, if I use X and Y as it is, then it doesn't change anything. But if I now add a little bit to my current X coordinate and use that as my new location, if I put my bug in here again, and now it crawls across the screen. So very, very quickly, by writing essentially 2 lines of code, one here and one in the world, I can get animated graphics on screen. And that is very important. That is just the motivator that we use to draw kids in, is to get graphics and animation and then interaction very quickly on screen. I can now add something like set location. Oh, set rotation is what I meant to write. And get the current rotation plus a little bit. And if I sort of change the location and the rotation at the same time, then it's rolling across the screen. So it's fairly easy to get an animation on screen. In a teaching situation, as I said, typically you would prepare a little bit, and preparing means that you can choose essentially the level of abstraction you want to expose to your students. So this is an example that might be a typical example as the very first thing that you do with students. This is one example that I've used a number of times with sort of 14, 15-year-olds where I've got a crab, and you can start by telling them about classes and objects, and we can instantiate the crab, and if I click run, nothing happens. And then we open the source code and check why nothing happens, and of course because there's no code in here, and then I can just write move. And if I write move into this and instantiate it again, it moves across the screen. And then I can write things such as turn 5 degrees, and if I do this, it runs in a circle. And the move and turn methods that I've just shown come from the animal class, which means as a teacher, by providing superclasses of the classes where the students actually work, you can decide essentially the API, the complexity of the API you want to give them. And so if on that day I think they're not ready to discuss parameters, then I write my method as I've done with a move, where it just moves a constant a bit forward. I could have done the same with a turn, of course, to just turn a constant angle. Or if I want to discuss parameters, then I write my turn method so that I can discuss what a parameter is. So this gives the teacher a good level of control over what level of complexity you want to expose. And for students writing this stuff, then fairly quickly there's the question, okay, what are the methods I've got available? And we can look at the animal class then. By default, here this one opens in documentation view. You can switch the editor here between the source code and the documentation. And if I prepare that as a teacher, I just switch it to the documentation, so that is what it will then show me by default. And I can see I've got here my move and turn method, and there's some other ones to check whether I'm at the edge of the world and where I can eat something. So I can now write code quite easily where I write if at world edge, then I turn something. And that means now if I run this now, I've got here, oops, had the wrong class selected. That means that this will now run around and turn around when it hits. And then again, of course, one of the nice things is that once you've written that, you can have many objects and can have them running around. And then you can create new classes. So I can say I want a new animal. Oops, didn't mean to do that. New subclass is what I meant to do. We can put in a worm, and I've got a picture prepared already. And if I compile this, I can put these worms into the world, and the crabs then like to eat worms. And so at the moment when they run over them, nothing happens at all. But then I can write code here that says if can see worm. So I can specify a class here that I'm looking for, and if I can see an object of that, then I want to eat it. And if I do this now, and I have a number of worms here, and I put a crab in, it's eating the worms. And fairly easily, you can also put sound in. So if I then do there's a play sound method, and I have a couple of sound files prepared here. And if I know the name of the sound file, it is very easy to just play it. So I can do that again, put my worms here, put a crab in, and up. Okay, it might get it now. It's not very loud, it's a fairly soft sound, but still. And so on. Oh, one last thing I should show you. We can add keyboard control fairly easily. I can ask the environment whether a key is being pressed. And every key has a name, so I can just ask whether the left arrow key is pressed. Then or the right one. if the left one, let's say I want to turn something a bit to the left and otherwise a bit to the right. And that's for beginners, these are sort of nice discussions. You know, if you've shown them that you can turn and then you point out, well, they always turn right, you know, how do you make them turn left? And then they quite quickly get the idea, you know, negative numbers. And then I, usually when I do this in a teaching situation, I first get the crab to turn randomly, sort of with a 10% chance or so it should turn a bit, you know, and then we get a random number and we say, okay, if we have a number, how can we now express a 10% chance? And you can get into nice discussions about some programming principles. But in this example here now, what have I done? I don't remember the names of my methods. That's what I've done. Well, I can show you how to look this up. The Greenfoot API itself is a total of 5 classes. So we tried very hard to keep it as small as possible. So there are only these 5 classes. That is all there is. And we can actually print them on 3 normal pages of paper. And the method is called isKeyDown, not keydown. So you see this is an integrated environment where documentation is linked in. You can get fairly easily to the documentation of the class. And so now if I have the crab and I can run around, I can now control this with my keys and can make it run around. And you can see this very quickly gets into sort of game-like scenarios. So what we typically do when I do sessions, sort of one-day sessions, is I often do sessions with school classes, just single-day sessions, where we take sort of 15-year-olds or so that have never programmed before to write a game within a day. And so the next thing is we add some other lobsters or something there that then chase the crabs, which is fairly easy because the code is almost identical to the crab, so you can do that very, very easily. And then you can have to run away from the lobsters and try to get all the worms before the lobsters get you and all that. What they typically do is they very quickly come with their own ideas. So I have my sort of prepared storyline to build this game. And at the end, just about, I always have them working in pairs. It works very well if there's 2 of them together discussing it. Almost every pair is doing something different. And that is one of the really strong stories here of using sort of graphical animations and games, is they come with their own ideas. They immediately get their own ideas. You know, if you, as a very first exercise, get them to print out the Fibonacci sequence or something like this, they might get there, and that's the end of the story then. You know, it doesn't lend itself to suddenly come up with, oh, I could also do this other sequence. You know, that just doesn't happen at that age. With game-like scenarios, you immediately get the reaction that they have things they want to do, that they want to add. And that is very powerful because that changes ownership. It's suddenly not your program anymore, it's theirs. And it's a very powerful thing. What they all discover very quickly is that you can just change the image. So just by setting the image here to something, and then you can, I don't know, look through there, make it an elephant. And suddenly, without changing any code at all, you have an elephant running around. And of course, that doesn't change anything programmatically at all. It's just a different image. But suddenly, they have killer sheep going around eating babies. And suddenly, they get really excited. You know, it's a very small thing. It is, technically, it doesn't really add anything. But suddenly, because they see they can do things, you know, and also things that you haven't told them, they get very much into this. The code you write, because it's standard Java, of course, it can become as sophisticated as you like. It's not only games. We often use games as sort of an early example, but here it's just a simulation. So this is an ant simulation. There are, 2 ant hills here, and there's ants running around, and there's food sources. And the behavior of the ants is actually very primitive. They just run around randomly until they happen to run into some food, and when they find some food, they run back to their anthill and they leave drops of pheromones. That's these whitish clouds you you see there. And if they smell some pheromones, they just turn away from the anthill and go in that direction, and that's all. And so if you have enough of them, you get this path-forming behavior. And there's no explicit code there to form these paths. This is emergent behavior that comes just out of the group here. So what Greenfoot does is it gives you a very easy entrance to getting graphics on screen and to make them move. And so every program that has as its output two-dimensional graphics is very, very easy to do. So games is one obvious answer, but simulations is another class of programs that works very well. And as you've seen, we don't have to write any graphics code. When I just did this, you actually, when you program in Greenfoot, you program only the logical state of the object. So you just set its x coordinate or its y or its rotation or its image, and the graphical animation is automatically done by the environment. So there's no graphics code to write. So that is educationally really, really nice, because that allows you to talk about the important programming principles and not about details of producing graphics. For teaching in schools, this is really something that at the moment is very hard to do. Programming in schools is, in the UK, probably worse than in the US. In the UK, there is a really dismal situation where there is almost no real computing left in the compulsory curriculum in schools at all. In the US, I don't know the details. My impression is that it's a little better on average, but also not everywhere. The only compulsory computing subject in the UK in high schools is called ICT. That's Information and Communication Technology. And what they do there is essentially learning to use Office. They teach them Excel and they teach them PowerPoint. And the closest they come to programming is to write some macros in Excel. So they make 14-year-olds do income tax calculations in Excel. And then they are surprised why they're bored. It's called ICT, but colloquially, the school kids all call it computing. They think that is computing. In fact, they think that is computer science. And they come out of it knowing for sure that they hate computer science. And they're well within their rights to hate it, because it is awful. It's just not computer science, but they don't know that. So a bit later in the, sort of towards the end of their high school, in a part that's in England, it's called A-levels, they can choose subjects. And one of the subjects they can choose is computing, where they actually do a bit of real programming. And a survey has just shown that the reason why so very few students choose that is their experience with the ICT course, because they have seen that computing is boring. There was a survey about attitudes to IT and computing recently, and that has shown that there is a real serious image problem. Computing is seen as boring, not intellectually challenging. There is a stereotype of these geeks with thick glasses sitting in basements with a pizza next to the computer screen, never talking to anyone. And large groups of kids get turned off before they ever find out what programming really is. And programming in any interesting sense isn't represented for most kids in the school curriculum at all. And so what we're trying to do is to open a way how programming can be brought back into school. And the problem, of course, one problem is that in modern programming systems, it's become more complicated than it was in days when there was BASIC or Pascal even. There was a smaller entry hurdle. Now there's a lot more infrastructure, and teachers, in fact, aren't well educated to do this and often have trouble doing this. So we want to bring tools back that make it as easy to get started as it was with BASIC 20 years ago. But then again, when we started, printing out a triangle of asterisks on the screen was really exciting. That doesn't really excite kids anymore today. So we try to do something that looks a little more interesting, but is as easy to get into in your first few steps. I think teaching office automation tools to 14-year-olds, that borders on child abuse. You know, that is, at that age, they should be creative. They should do things. They should invent stuff. They should build things. You know, they should have their ideas and make them happen. And that is, you know, what we need to bring back. Most people I know who work in computer science have started, you know, got in through programming because programming was exciting. And so I think programming is a good way to get them interested in computer science. Most of the examples I've shown you so far were these essentially bird's eye views of a world of actors that run around. It doesn't have to be like this. There are other things you can do. I just very briefly show you some examples. So here's a lift simulation, for example. So that's a side-on view where, you know, you have 6 floors and lifts going up and down. And now you can then, you know, write lift control algorithms or something like this. Or another example is just nothing really very meaningful at all. Just something to look at. It's just a net of dots and a bit of gravity. And if I grab one of those, I can drag them around. You know, and so you can just, in examples like this, the nice thing is that you can really concentrate on the logic of the movement and don't really have to write the graphics code. There are some applications, because this is not a toy language, because this is full Java, you can make it as complicated as you like. And there are uses of Greenfoot in universities as well. I've got a colleague who is using Greenfoot in an agent modeling course for writing where they develop essentially AI algorithms for behavior of agents. Because, you know, you can put any algorithm in there that you want. And the reason he's using this is just because he's not interested in doing the graphics, and you get the graphics for free essentially here. You can then just concentrate on the logic, and the Greenfoot environment just does the graphical animation for you. Another colleague of mine at the moment is working on developing examples where the topic matter is chemistry, where you have, you know, reactions of molecules on screen, where you don't learn only about programming, but you learn something about chemistry as well. So there's another possible level of learning where you can actually teach something about the subject matter, which then you can manipulate through code as well. What have I got here? And when we have the animated graphics and we have keyboard control, then very quickly, of course, we have game-like scenarios. So here I have to land this rock. Okay, that wasn't. I have to land that very, very carefully. I'll try once more. So I have to come down very slowly. Okay, I give it one last try. I have to concentrate now. Okay, you can try after this talk yourself whether you can do any better. When you actually get it done, there's a flag coming up, which is, of course, a grad student of mine wrote that, who is obviously Danish. That's why it's this flag. But the reason I brought this up is just to show you the sort of a possibility how you can do, and now that blew up as well, how you can do testing with this. Because you can manually instantiate any class, and you can manually call any method, you can do very nice, very quick testing. So as soon as you finish writing one method, you know, you can instantiate it and you can run it and you can see what happens. And debugging is almost implicit because a lot of the behavior is visual. You immediately see if it goes wrong. You know, so in this case, for example, I've got my explosion here, which I can put into the world, and then it does a bang. But one thing I've done is I've written it so that when the explosion touches anything, that thing explodes. So if I put any objects in here, let's say the flag, let's say I put some flags in here, and then I put an explosion somewhere on one side, I get this chain reaction, and I can just try this out. And this chain reaction isn't explicitly programmed. It's just the behavior of the explosion. And the code for that is actually quite simple. This is the code that does it. You know, when the explosion acts, it just goes bigger and smaller and then disappears. But here, it just says, every time when it acts, it gets the set of of overlapping objects. There's a get interacting objects, and the null is a filter. I can essentially filter here to a certain class, and I say, without having a filter, that means I take any object that comes along. And then I just go through them, and I say, if that object is not itself an explosion, then I just put an explosion where that object was and remove the object. And that's it. And that you get this nice thing. So this interaction gives you a lot of possibility of trying things out very, very quickly. So if you're a student developing something, or if you're not a student either, because I try to do that a lot, it actually is quite good fun once you get started. You don't have to complete a whole scenario before you see the first effects. You write one method and you put it in and you look at it. That it goes. There is no test drivers to write, or no complete application. Once you have a partial thing going, that partial thing will go. The quality of the animation you can achieve is good enough to actually look reasonably. So here, for example, there's a sort of, you can see, there's a lot of, this is actually using Greenfoot, the example where I've seen most software reuse actually happening. You might have noticed that that's the same explosion as I just had in the previous one. There is a lot of possibility to just take classes from existing things and put them over. So here, this is just the standard asteroids. So you see that there is a, the animation certainly is good enough that this looks like something you can play. And so students can achieve something there that they can actually show around. That is, we wanted to achieve the same sort of quality of code that you can do with all those Flash games that are now on websites. And from a motivational point of view, showing it to others then is very important. That's very, very powerful. So one thing we have done here is we've got an export possibility. We can export it as an application, which is essentially just generating an executable jar file. Or we can make a web page out of it. Let's say I put that on my desktop and export it. And then it writes me a web page with an applet on it. And here I have then, this is what it generated. And so if I open this, I get this in a web browser, and there's my game, and I can play it here. And so, of course, from perspective of learning to program, that doesn't really add very much. But as a motivator, that changes a lot. The problem with this generating a web page, of course, is that you still need a web server somewhere to make it public. If you do this, you have it now in a web browser on your own machine, but you still can't send the URL to your grandmother. So to solve that problem, we are just at the moment working on building a web server, a public web server, where anyone can just put their stuff up there. So if I here do my export, and there's a publish functionality, and that's at the moment still experimental. Actually, I should reset this and then put that a bit together so that I get an image. Because if I do the export, I have my screen image here, and I can use this as my icon for my game. And then I can give it a title. And if I put my username and password in and export this, this now builds the same thing, the applet and the web page, but it puts it on a public web server, which I hope is up at the moment because there's people working on it right now. So if I go there, this is now really live on the web, and here's a page which I should reload because I had that up earlier. So, okay, I just did I didn't look at my dialog. I reloaded it because I noticed it isn't here, because if it's recently added, it should be the first one here. That is right, that is right. Let's try that again. Yeah, that's essentially the same thing that I put on there earlier. So there is already another version of this scenario on there. Okay, now it's said complete. So if I go back to that page and I reload this, there should be now our version on here. So this is the one we've just put on here. So this is, we think about this as something like YouTube for games, you know, for programming games. And so the idea is, first of all, that through this thing, there's a strong motivational thing, because of course it has all the sort of standard, you know, social interaction stuff that you have nowadays with ratings and leaving comments and all that kind of thing. And people can really show around their work. And we have sort of the hope that through this, people might get interested in this through actually playing the games. So we'll have some games on sort of featured games at the top that are actually sort of fairly nice looking, and then links that show people what the source code looks like and how they, you know, open it in Greenfoot and change it. That asteroid thing, that's the arrow keys in the spacebar. Turn your sound down. Okay. So, here the weather thing. I should maybe I don't really want to show you a lot more, but maybe as a last thing, just to give you one other idea. One other nice thing you can do, of course, is if you get live data somewhere from there. So here, for example, if I click Act, it goes out to some weather server and gets actually real-time weather data. And so there's a whole number of things you can quite easily do. And there's a question, of course, whether or not, you know, Java is the best language to use for something like this. There are, well, it's a blessing and a curse at the same time. You know, Java clearly imposes a lower bound to how young the kids can be doing this. You know, I've used Greenfoot with my own daughter, who is 8. Oh well, we started when she's 8. She's 10 now, and that works with sort of sitting with her one-on-one and helping her out. You know, I have to help her a lot with the syntax. You know, just the question of forgetting brackets and things like this is, at that age, it is really still a big hurdle. So it's clear that at that age, for a classroom situation, that wouldn't work. That's too young. For a sort of one-on-one situation, it works. But it was also interesting that all the problems with syntax, she got the concepts really, really easily and really quickly. So with a different language, you could probably go lower down in age. We use this mostly sort of with kids 14 and upwards. But then, of course, there is the good thing, because Java is it's not a toy language, it's a full language where everything you want to do is supported. There is really no limit about how sophisticated you can make it, and you can do really interesting stuff. It scales, you know, because it's really just the standard Java compiler. So you get all the benefits of having a real language in there rather than a toy language. But it's a trade-off. What we are trying to achieve here is to create a situation where the first contact with programming can become really engaging and interesting again. You know, where we have sort of two goals in mind. We want to draw them into programming. We want to show them that this is something that you can enjoy, that can be you know, good and satisfying. And at the same time, what we don't say openly is we actually want to teach them good programming principles. So we want to discuss things such as classes and objects and separation of concerns. And the visualization of the classes and the objects is important, so that they can see, you know, that there are separate objects and they interact and they can get references to another and they communicate by invoking each other's methods and parameter passing, and all the important concepts in object-oriented programming get automatically discussed. The other thing that we're trying to do is we are trying to see the kids and the teachers both as target groups. Now, teachers at school level are often overwhelmed with sort of the complexity, and they don't really know how to teach well either. So what we're trying with Greenfoot is to give a very clear guidance about, you know, what the concepts are that you should be discussing, because we try to expose them explicitly in the interface. You know, there are classes, there are objects, there are methods, and all the things we think you should talk about, you know, are explicitly there in your face. So that gives a structure about what you should cover. We're getting closer to the end of the time, so I think I'll stop here and just leave another few minutes for questions, in case there are questions. But I'll stop my talking here at that point. Yeah, I think you were first.
What do you think of Flash? I don't know if this is on. I don't know. What do you think of Flash MX as a teaching tool for writing games like this for kids?
I think from a language point of view, you know, from a teaching point of view, Java is nicer than Flash. I'd rather teach Java because it represents some of the concepts that are important to me much nicer than Flash does. From just performance of the technology, Flash is clearly winning at the moment. You know, if you compare performance and startup time, for example, between applets and Flash, of course, applets really has some catch up to do. Luckily, at the moment, the story we're hearing out of Sun is that they're working on this, you know, improving the sort of user experience for using applets, and that would be nice. There still is, you know, applets are still a pain point where, you know, you get different errors in different browsers and all the, you know, you all know some of the problems. So from technology point of view, Flash actually works better at the moment. From a pedagogical point of view, Java is my clear preference. There was a question there as well, and Josh, I don't know. Do you want to go to the microphone?
Mine's real easy, so I'll ask when my brother comes up. So how many lines of code, roughly speaking, in the Asteroids program?
That's about 200 lines of code. So that is something, the Asteroids program, that is something that a total beginner can achieve after 2 or 3 months or so. So it's not very far out there. As a teacher, I can write that in an hour and a half or so. You know, so that is that's the other thing. As a teacher, the scale and complexity of supplying these examples is manageable. You know, for in acceptable preparation time, and students after a reasonable time of study can get there. For that teachers can write that is important, because often the way you start teaching the early examples is sort of with fill-in-the-blanks exercise. You might give them the asteroid scenario almost done, but the rocket doesn't move. You know, and then the early examples could be to just, you know, do the rocket movement. You know, everything else is already there. Yes.
I have a few questions. Let's see. Start with, could you go back to the crab world? Do you still have that? So I'm wondering, I'm sure students try this very quickly, and I could download it and try it myself, but I'm just dying to know, what happens if you try to eat a worm and there's no worm there?
Well, we can look at the, so if I do this, you know, say, if I do this here, which means it would eat a worm at every step.
Yes.
Right?
Yep.
And I compile this, I put my crab in its elephant costume in here, nothing happens at all. Oh. And the real answer, of course, is whatever the implementer of the animal class has written there is what will happen.
Okay.
What I happen to have written here is that I just ignore the fact. So here in my eat method, whereas my implementation of my eat method is here, I just see whether there is an object at, you know, offset 0, 0 from where I am, which means whether there is another object of the given class, of the worm class, at my location. And If there isn't, I just don't do anything.
So I guess what I was really wondering, is there an exception mechanism visible to the user?
Could be. So if I now decide to throw an exception here,
Yeah.
or if I call one of the API methods that throws an exception, that is visible. So if I do this now, if I don't ignore it when it's null, but I actually try to remove null, I would expect this to give me an exception. And if I do this, immediately this stuff pops up here.
Okay.
And I get my exception.
Okay. So my other questions are at a higher level. So you can save applications and run them as applets. Very cool. Can you run Greenfoot itself as an applet?
No, currently we can't.
Have you thought about it?
We thought about it. It is technically not easy, and we decided at some stage that it's not worth the trouble. I mean, that it's sort of more trouble than it's worth. Part of that is that Greenfoot runs internally 2 virtual machines, one to run the user code essentially, and one to run the environment itself, and there's communication going on. And all that, actually doing that in an applet, you run into all sorts of problems with the security. So there would be so much fiddling necessary to make that work that I think, and I don't see a strong enough benefit to actually justify that. So downloading it, running it locally our judgment is probably the preference for most people anyway. So that I don't think it's in sort of cost-benefit payoff. I don't think it
Okay.
comes out.
Fair enough. That's another thing I was wondering about. So this is, you're starting off introducing kids to programming for the first time, and it's a object-oriented language, which isn't how I learned to program. So I'm just wondering, do you have enough data on what happens? How do they deal when they encounter a procedural language for the first time? Are they puzzled?
We have data from that, not from Greenfoot and school-age kids, but we have done. There is data that was done at the university level, where something like 5 to 10 years ago, there was in the computing education community a big discussion about object orientation, how to teach object orientation, and when to teach object orientation, and whether it should be taught first. And many people have heard probably about the problem of the paradigm shift, going from a procedural to an object-oriented language. There are studies that there really is a problem that way, going from a procedural to an object-oriented language, and sort of studies show that the other way around, there doesn't seem to be this problem. Going to a procedural language from an object-oriented one seems to be a lot easier than the other way around. So we haven't done any studies where people started at school age, but I don't expect there to be a real problem.
Okay, thanks a lot.
So I guess the 2 questions I wanted to ask was, the first one, I see you doing a lot of things involving subclassing actor, but it seems like you just set up the background with an image and the size and the granulation, and that's all you're doing with it. Is there kind of any functionality, say, to change the background?
Yes, that can all be done programmatically as well. So the background can change, the image of well, if I open the end scenario again and just show you quickly, it's maybe clearer to see here with the actors, but the same is true for the world. So here, for example, the pheromones here are actors as well, right? And the image of the pheromone is not loaded from an image file, but drawn dynamically at runtime, so that it actually just draws a circle with a certain size and an alpha value. And the image dynamically changes. So the image of an actor has an image, but that can be loaded either from a file or you can draw it programmatically. And for example, the count here is also an actor. There is somewhere here is the counter, and that is just a transparent image where I'm writing some text onto a transparent bit of image, and that updates itself automatically.
Okay.
So, and you can do the same with the background of the world.
Okay. Let's see. What kinds of requirements are there to run this? Like, you obviously need a compiler, which means having the JDK.
Yeah, it requires JDK, Java 5 or later.
Okay.
Okay, we are running out of time. So, last question, or is that? Oh.
I just want to ask what you, the tools seem really great. I was wondering if you were also working on lesson plans or like a sample course or something just to actually bring to the classroom.
Yeah, the question was whether we're also working on material lesson plans to go with this, and the answer is yes. That is, in fact, at the moment, that is our main focus. The software at the moment is at a stage where it's working and stable, and that's all well, and we're extending it a little bit. But that is, in fact, the main thing that is needed next. There's a little bit already there, not very much, but we're working on this at the moment, and there will be more available very soon. Okay, we are out of time. Thank you for coming.